Hello everybody, welcome back to another edition of the Modicon M221. In this video, what we're going to see is how we can configure the user-defined functions that we have in the software. So let's go to the presentation. So in the software EcoStruxure Machine Expert Basic, we had the possibility to create our own functions. Okay, so in case we want to make a mathematical equation or another calculation, we can create our function, so we don't use some part of the code, okay, for that, and we can replicate the same. For example, if you are trying to calculate, I don't know, the average value for analog input, okay, and you have several analog input, you can use this user-defined function that you have created, so you don't need to duplicate the code, so you can maximize, optimize the code that you have. So in order to create this, there is a specific part in the programming, as I show you here. Just take the pen. If you go to the programming, okay, and you already select the task, you should be able to see here the user-defined functions and user-defined function blocks. This part, we only cover the functions. We're going to see later the function blocks. So if you select the user-defined functions, okay, you can click over here, okay, to add a new function, or you just make a right click and then add the function that you want. Once you have it, okay, and make right click on the function created, you should be able to rename the function, so you can easily see that in the code and identify that the function that you want to use. So once you create this, let's go to the software so I can show you much better. So I have this new application, apply, configuration, doesn't matter this. So if we go to user defined, you should be able to see this icon already visible in order to add the user function, or right click, add user defined function. If you already have a function, you can import it. So once you have this function, right click, you can change the name, okay, so blah blah, okay, and you can see here in the bottom in this message that how is the syntax for you to use this function block. At the moment, this function block doesn't have any parameters inputs, so you can see there is empty. But as soon as we add parameters, okay, and apply these changes, let me just change. As soon as we do this, you should be able to see how it's going to be the syntax, okay. So let me just try to do it in this way. Doesn't show you the right way to do it, okay, but it's going to be the syntax of the parameters that you have, okay. So these just change this like this, okay. So the idea of this user-defined function is to have one function block with parameters in the input, and it will only give you one parameter, which is the return that you have over here. So you need to specify the name, for example, output, our output for real, okay, and you need to specify the type, word, double, or float, okay. And based on this, it will give you another kind of syntax that you can see over here, okay. And it's important for you to it's important for you to define if the variables that you're going to use in the block are parameter or variable. The main difference is parameter are like the inputs of the block that you're going to use, and the variables are like the auxiliary variables that you use in the local program that you're going to have, okay. You can change here the type, double, float, or you can also change the name of the value. For example, I don't know, bar1. So as soon as you change this, okay, to the type that you want, then the syntax is going to be changed, okay. So I'm going to apply this. Now that I have this, here in the top, here is. So here you can see how is the syntax for this. So I have this input over here, the return value. Okay, there's gonna be this, okay, the name that I have, and then as parameters of the input of the function block, I have only this bar1, okay, because this bar1 is the one that I have defined as a parameter. If I define the bar0 as a parameter, I should be able to see that over here. And there we go, param0. I need to change this bar0 and apply, and there we go. Okay, this is how you can see the syntax of how to use that in your code. So let's continue with the presentation. I already explained this part. Let me just change the view. So as soon as you add the function block, you should be able to see the return value, that you only have one return value. That's going to be the output. You can see here the syntax. And then you have the parameters. Okay, you have parameter and variable, and the variable are like the local variables that you have for the program, okay, in that function. And these parent are the external that you can use as an input. So in the top, as I showed you, you can see the syntax, and here you can see an example how to use it. So the name of the function, then parentheses, and then comma between all the variables that you have, okay, and you need to match the type. Okay, in here, in this, I'm using %mf because it's a float value. Okay, if it was the word, it should be md, and if it's a word, mw. Okay, so if we continue with this, okay, so my original idea was to based on the high-speed counter that we see before, how to calculate this and make the calculation and everything in an easy way. This is going to probably take more time, so what I'm going to do is something different, that we're going to see that on the PNID. That basically what I want to show you how we can make a scaling of analog input. So what I'm going to do instead of this, okay, I'll show you how it's going to be the result. This is the calculation that we should be done. This is how it's going to be the inputs and outputs and everything. Okay, so there we go. This is going to be the solution. But what I'm going to do instead of this is, let's see, forgot it. Want to make this calculation. Okay, so I'm going to make a linearization. Okay, so imagine that you have a temperature sensor that you're using, for example, using a temperature sensor with the output of voltage 0 to 10 volts, and then you have the analog input that you need to escalate to receive the centigrades. So it can be, for example, in this case, should be minus 10 degrees to 38.5 degrees. So if we want to make this is a linearization, so we can make this calculation that we're going to see later, and we need to use this formula to make it work. So we can easily add the analog input that we have with the controller and make the calculation. Instead of using that, what we can do is to, okay, we just need to we can add a function block, a function, user-defined function for this. So if we go back to the software, we can specify this scaling. Okay, the input is going to be our scaling. It's going to be float. The parameters going to be, for example, I'm going to use float as a input. I'm going to add a parameter for the parameter A, CFG A, and another parameter CFG B. Okay, so this is going to be my my program. Okay, it's going to be this calculation. So I want this to be variable. It can be fixed, but the idea is to change this. Okay, so A and B, and this is going to be the analog input. So this is simple. I just have the return. Okay, should be scaling. So it's going to be the CFG A multiplied by the input plus CFG B. It's just a linearization. Okay, so this is going to be the calculation for the scaling. So here, what I can do in the POU, the first thing that I need to do is to change the analog input. So for example, this analog input I'm going to use the embedded. Okay, I'm going to specify analog input temperature. Okay, it's going to be from 0 to 1000. So I'm going to use this one, and I'm going to move it to a percentage NW value. Temp. Okay, now this percentage NW variable, as my function block requires a float value, okay, I'm going to convert this to real percentage NW 0. Now what I'm going to do is to call the function block. So here I need to remember the syntax. Okay, it's going to be like this. So oops, here it's going to be scaling. No, not that. Scaling. Here, this is going to return a value, percentage F4. Scaling. You can see here the syntax, how it's going to be float, float, and float value. So here I'm going to use the input already converted to real. Here I need to use the configuration of A and B. So in my case, we go back here, A has this value. Okay, I'm going to copy this. Hopefully, yes. And the other one, the B. Okay, just go back here. B has minus 10. So minus 10. Okay, so I'm scaling this analog input. So imagine that you have another analog input, so you can add the same scaling and call it a different. So let's try to simulate this so we can see the behavior. And play. Okay, so right now the value that they have is 0, so it's going to be minus 10. It makes sense because it's the other point of the scale. So if we open the simulation here, let me just zoom in. You can see I have the 0 and then it's going to be the minus 10, okay, which is fine because it's going to be this point, okay, the first point. And then if I use the 1000, it's going to be 38.5. So if I select this one, the analog input, I put it over here. You see, it's over there. You can see how it's going to be decreasing, okay, based on the value. So if I add 508 in the calculation, here, 508, 14.6, 14.6, 14.6, okay, you can see over there. So this is how you can use the user-defined function. Okay, it's not a function block. We're going to cover that later. So the main thing that you need to know is that in the function, when you create the function, okay, it only allows you to have one result. Okay, so you only retrieve one value in there. So it's good to make a quick calculation once you have some data. Okay, that's the main idea of this. So this is how you can make the user-defined functions. And I forgot to show you something. If you want to share this function block or use it in another project, you just need to right-click on it and export. Okay, so you can export the code, and then you can import it in another project. Simple as that. I believe that's it. So this is it for the user-defined functions. Thank you very much for watching this video, and I see you on the next one.